I'll just share my PowerPoint and then check whether
Okay.
visible or not.
Okay, till that time I have to give the intro, ma'am. Just wait.
Is it visible?
Yes, ma'am.
PowerPoint is visible. All right. Thank you.
Okay. Good evening to all. I, Rakhi Chaudhary, welcome you all on behalf of our President, Dr. Shubhashree Sarkar. And now I'm going to welcome our resource person, Pragya ma'am also. Good evening, ma'am.
Good evening.
Can we start now?
Yes, sure. Is there a black window in between or is the screen clear?
Uh, yes, ma'am. Corner, no?
No, not corner, in the middle. Is there a black window?
No, ma'am.
Okay. So it's clear to you, everybody.
Yes, ma'am.
Okay. So a very good evening to all those who have joined here, and you are welcome to the session Competency-Based Science Education. I'm sure you must have attended lot many webinars on what is competency-based education. Uh, you must be aware that competency means the ability to do a task efficiently. And if we want to do a task efficiently, if we want to perform a task efficiently, definitely we must have the knowledge, the skills, and the attitudes required for that. I'm sure everyone knows this. So today we will be talking about how we can have competency-based education in science in particular. And the competencies in science, they may be slightly different also. So what is it that we mean by competency in science or science education? And then how we can execute that in the classroom. For that, I'll be talking about some of the ideas. So going further, I'll just lay out a map of scientific literacy framework. And uh, the share has stopped.
Yes, ma'am.
Oh, just a minute. Share. Is it visible? Now is it visible?
Yes, ma'am. No.
All right. So you see, in daily life situation, we have so many instances where there is a new situation in front of us, and we figure out the situation by asking questions to ourselves and then try to make meaning out of whatever we are seeing. So we observe things carefully, we notice things, then we ask questions to figure out what is happening, what is this, what is that, why is this there, what is the connection of this thing with what other things are being seen in this situation, or somebody might have said something and we must be wondering why he is saying that, and what are the implications. So we just try to figure out situations by asking lot many questions. Now these situations in today's world may be personal, maybe societal, maybe national, maybe global. So there is a context to every situation. And because the education relates to our daily life, these contexts also matter for the scientific literacy. When we talk about science education, we are aiming for our children to become scientifically literate. And now we are discussing what is the meaning of being scientifically literate. So in this context, I want to discuss what are the different contexts that we come across or our children are likely to come across. One would be, so these are the situations which involve science and technology, and they can be personal, they can be local or national, or they can be global also. Now, uh, these contexts, understanding these contexts requires people to display some competencies. And what are those competencies in particular relation to science? This can be that they might need to explain a phenomena scientifically. They might need to interpret data and evidence scientifically. Nowadays, you might have seen in newspapers also, there are a lot of graphs, there's a lot of infographics, and we have to interpret, make sense out of that. And then uh, when we are giving our presentations, we may need to use that data as evidence. So that becomes a competency. And then we may need to evaluate and design scientific inquiry. We see something, we want to understand its cause, we may need to design an experiment, how we will collect data, and then we may need to look at the data, analyze and infer from there, and then evaluate whether what we thought was right or not, or whether this is useful for a particular criteria or not. So these are some of the competencies that a scientifically literate person is supposed to have, so that they can make meaning of different life situations that involve science and technology. Now, how we do so, or how people uh, develop these competencies, that is influenced by two things. One is knowledge, and the second one is attitudes. So, as far as knowledge is concerned, what do people know about the natural world and the technology? That means the knowledge of science. And also, in this comes the knowledge of content of a subject, maybe biology, chemistry, astronomy, space science, earth science, whatever. And another thing that they have to have is the science itself. That means the knowledge about science. What do we mean by that? What are the different procedures that the science has? How does it collect data? How do we set up experiments? How the science tries to minimize the errors in a procedure? So these are different procedural knowledge about the processes employed in science. And the other is epistemic knowledge. That means the knowledge about the structures of science. What is a theory? What is a hypothesis? What is experimentation? All these, the knowledge about the ways and terms of or constructs of science. So all this knowledge plays an important role in developing the competencies. And then what are the attitudes that are required? How we respond to the science issues, how much interest we have in science, how much do we value scientific approaches to inquiry, and how do we develop responsibility or awareness towards resources and environment. So this is the meaning of being scientifically literate. So now if we want our children to go out in the world, which is continuously changing, and it is changing so fast that 3 years back we did not know that everything will be shut down and we'll be required to teach online. So world is changing very fast, and it is definitely changing. So if our children have to go out in that world, new situations about which they haven't even learned in the classroom, new professions which we do not even know will come up, new problems whose solutions will have to be found out, nobody knows anything about it. Then how do we train our children? We have to train our children to be able to look at new situations and to be able to understand them, make sense, understand cause and effect relationships, to be able to explore, maybe scientifically, maybe do surveys, and then whatever is the result, they may have to analyze, infer, predict. What all these things are the scientific competencies that they will have to have, so that they can live in that continuously changing world. So the task behind us is with in front of us, not behind us, in front of us is this, that how do we develop these competencies? And that is why we are talking about competency based science education. So now let me break it down into more smaller steps, or easier steps for us, which we can implement in the classroom. So our map looks like somewhat like this. And what is this map? First, we have observe. So we have to make our children used to observing things very, very keenly. We may be looking at things in front of us, but if we are not observing, many of the things do not even come to our focus. And it's not that we automatically learn to observe. We have to train our children to observe keenly. So that is one competency, to be able to observe keenly has to be developed in the classroom. Then we have to make them reflect on what they are observing and tell us what they are thinking about it, because we don't know whether they're reflecting or not, and if they're reflecting, what is it that they're thinking. Then we have to train them to ask questions. Right now we train them only to answer questions, but in real life we don't make sense by answering any questions, because nobody is ready with any questions. We have to frame our own questions to make sense. Then we have to train them to connect what they are observing with their past experiences, or put the new learning into a new situation. But that can be done only when they connect the new situation with past situations, or they connect the a solution with the concepts in the theory, or what they have learned in practical. So connecting is a big competency. Then experimenting. How how do they design an experiment? What are the things that can be explored? What are the things that can be measured? And then how do we collect data? How do we tabulate data, or how do we represent data, maybe through graphs or charts or whatever? Then how do we analyze this data? If we analyze the data, how do we make inferences from there? And if we make inferences, can we review them? Can we argue or debate about them in light of any criteria? Can we evaluate whether they are right, wrong, in light of our theoretical constructs? And then they may also require to predict that, okay, if this is the result, then what may happen at in future. For example, they may know the equation of motion, s equal to ut plus half at square. But then can they use it to predict how far an object will go after, let's say, 10 seconds? So this ability to be able to use scientific principles or the results of experiments to predict something in future is also another competence. And then to be able to review the results and understand that they may need to re do the experiment, because something may not be gelling, something may not be congruent, something may not be logical. So then they need to revise, review, re-experiment, re-explore, and then come back to the conclusion. So these are some of the competencies which will lead us to that scientific literacy we talked about in the previous slide. So now let us see one by one how these competencies we can develop in our classrooms. We may be teaching middle school, we may be teaching secondary school science, or we may be teaching even higher secondary physics, chemistry, biology. But these competencies remain the same, whether you talk of physics, chemistry, biology, maths, or any other scientific subject. So first is the first competency here was observe, then reflect, and then question. Now, observing, reflecting, and questioning. This can be very well nurtured in the classroom by a routine that all of you know, all of you must have heard about, and that is see, think, and wonder. So, we may show them a picture, we may show them a video, we may show them a demonstration, and then we may ask them, what do you see, and what do you think, and what do you wonder? So when they see and tell us, we know that they're observing. And when they share in the classroom, then one person says something, the other person says something, the third person says something. All their observations collectively lead to enrichment of all people over there. So even the competency of collaboration, even the competency of learning from different people, that is automatically developed here. And then when we say, what do you think, and they are telling us what they are thinking, we know what they are reflecting. And at that time we can judge that what they are thinking may be right, may be wrong, or it may be something absolutely new that our attention is being brought to. And that can lead to more explorations, better enrichment, and more sense making. And then when they tell us what they are wondering about, that means they are telling us their questions that are coming to their mind. And that is the ability that we have to really, really nurture, because any new situation you can only make sense of by asking questions and then trying to figure out the answers. So we must understand that here there is a paradigm shift. Right now all our efforts are focused on letting the children write the answers to the questions given in the examination. But in real life, when they go out in the world, there'll be nobody standing with a question board or a question paper. They will have to raise their own questions to make sense of any situation. तो इसलिए ये बहुत ज़रूरी है कि हमारे बच्चों को हम क्वेश्चन करना सिखाएं. हम बाजार भी जाते हैं, एक कपड़ा भी खरीदने जाते हैं, तो हम क्या अपने से सवाल करते हैं? क्या हमसे शॉपकीपर थोड़ी पूछता है कि आपका बजट क्या है, आपको किस ओकेजन के लिए कपड़ा चाहिए, या आपको सूट करेगा या नहीं. वी आस्क आवर सेल्स whether this cloth, this dress is suitable for the occasion that I want to wear it for, whether it is looking good on me, क्या ये समर विंटर के लिए सही है या नहीं है, क्या ये मेरी पॉकेट को सूट करती है कि नहीं. तो हम कैसे डिसाइड करते हैं कि हम क्या कपड़ा खरीदेंगे? बाय आस्किंग लॉट ऑफ क्वेश्चंस. So this is what I mean, that in any situation, how do you make sense of the situation? How do you evaluate? How do you take decisions? By asking questions. And that is why it is very important that we nurture the competency of asking questions. So this see, think, and wonder routine can nurture the competencies of observing keenly, reflecting on a situation, and then raising questions or noticing the questions that are coming to our mind, and tell them. Because many questions keep coming to our mind, but we ignore them, right? So now the competency will be that we notice the questions that are coming to our mind, and then we also speak about them in the classroom. So let us see a few situations. Now here I am going to show you a video, and write in the chat box, what do you think is happening? This is a very short video. Now don't be in a hurry to answer. Look at the whole video and then write in the chat box. So see on the screen. Yes. So one thing watching is heartbeat. That is the video about. But what more do you notice? Yes, heartbeat being monitored. That's fine. But what was the inference that you made? You were rightly observing that this is about measurement of heartbeat, and how what else is being shown? Okay, some exercise. So what do you think is happening in this video? He's watching heart function. Okay, then what else? Hard work. The he felt relaxed after therapy. There was no therapy, I'm sorry. Cardio exercises. What about cardio exercises? Watching heartbeat. So what? Physical activity. Observing heartbeat and decides to be active. Okay. Now, I personally think that what is being shown here is the effect of movement of the body on heartbeat, right? Because when he was sleeping, the heartbeat was, let's say, 52. And then when he got up, it increased to some 60s. And then when he started exercising, it became 100 something. And then he ran out. So you see here, uh, it is not just heartbeat or cardio exercises, there is more to it. And that is why it's very important to tell what are you thinking. So are there, if many people are telling what they're thinking, then everyone becomes enriched. More varieties of thinking are exposed, and therefore, collective learning is always better learning. So, simultaneously, this activity is also nurturing the competency of collaboration. But are there any questions that are coming to your mind after watching this video? So, if you could write in the chat box, if you could write in the chat box, in different ways trying to see heartbeat, that was observation, that is what you're thinking, right? But what are the questions that are coming to your mind? For example, in my mind the question comes that why should the heartbeat go up because of exercise? Supposing I am a new student, I have no idea about biology. As it is, I am a physics teacher. So maybe I am thinking in my mind that why should the heartbeat go up due to the exercise? Why does the body require that the heartbeat should go up, right? So this is how we can see something, we can uh, give reflections, and we can raise questions. Now another way to do it is through interesting photographs. Now tell me, what do you notice in this photograph? I want you all to write in the chat box, what all do you see in this particular photograph? There is light through prism is being shown. This is by a photographer, Berenice Abbott, and he was a very famous photographer. So reflection of light, somebody saying beam of light, somebody saying dispersion of prism, somebody saying laser show. Now this tells us that what all is the various things that people are noticing. Now, if I were to describe what I am noticing, I would say that I see a light source. For example, I would say that there is a light source from which six rays are being shown, and then they fall on one surface of the prism, and from there they are going inside, and they are not going straight. So there is a little bit change of path. So then when these rays are striking this particular face, again they are going, some of them are going out, but some of them are getting reflected. And then when they strike this particular face, again some are going out. Apart from this, I see here brighter blobs, brighter regions of light. So this is my observation. now, when some of you are writing reflection and refraction, that is not my observation, that is my inference. Because I know that the light, when it bends, it is called refraction. So I'm inferring from here that the light must be undergoing refraction. And also, when it is changing its path, not going out from here, then I would say that this is total internal reflection. So light is reflecting from here. And then I would ask a question that why this part is so bright, this part is not bright, this part is not so bright, but these portions are very, very bright. So the question that comes to my mind is why are these bright? And then I also notice that intensity here is very less, intensity here is more, and here the intensity was maximum. So there are so many things that I can notice. I can also notice that there is no shining here on this part, but here there is a white shine. This part of the prism is shining, but this part is not shining. So there are multiple aspects to this situation, and then I have so many questions that I can raise. Then look at this picture, again by the same artist. Now I want you to write in the chat box, what do you notice here? And what are you thinking about this situation? And what are some questions that are coming to your mind? So I would love you to kindly interact and write in the chat box, because some of you may not even be teaching physics, but yet your observations are very important, because when you're looking at this picture, what is it that you are noticing and what is coming to your mind? That is how a new student will think about it. So it's important that even non-science teachers who are here, they write what they are thinking about it in the chat box. Yes, please. So can I see some pathways of bouncing, movement of ball, motion being taught? Okay. What else? Uh, Dropping a ball is shown. Slow motion. Okay, wonderful activity. No, I don't want you to give me medals right now. I want you to please write down what you're observing. All are of same height. Now, this is debatable. Do you think that all are of the same height? Amplitude decreases with respect to time. Now, if I were in your place, I would say that I see a round circle placed at different positions. Initially, there is lot of more distance, then the distance between them is reducing, and then here these circles are very close to each other, and then again the distance goes on increasing, and then again the same spheres or circles are placed, but this time the height to which they are placed is lesser, and then again lesser. Now, what do I think about it? These are my observations. I am not thinking anything. But now I am thinking that this might be a ball which has been dropped from some height, and that is why the height is reducing, because it is bouncing. So the question in my mind that came was, why is the height reducing? And then I thought that maybe it is a ball which is dropped from here from a height, and it is rebounding, and its height to which maximum height to which it rebounds is decreasing. But then another question comes to my mind, that why the distance between these balls is more initially, and then as it goes up, the distance between the ball is shown to decrease. Now the question that is coming to my mind is, why is this decreasing? Now, what is the answer to this? Can anybody tell me why the distance between the different positions of the ball is decreasing? So, this is the thing to analyze. This is the thing to discuss, because this that means this photograph must be showing the position of the ball after equal intervals of time, and that is why initially, when the speed is more, it is traveling more distance. But as it goes up, the speed must be decreasing, and that is why the distance between two consecutive positions has decreased. And then here you see there is hardly any vertical distance. So, just from the photograph, there are so many questions that can come to mind, and then people can start thinking about it. Now, when you're talking about conversions of energy, that is also that may come to mind later on. But immediately from the photograph, these are the questions that come to the mind, and that can be explored further. So this is the role of giving photographs which generate scientific questions. Then Another important thing is the ability to make connections. So, supposing you give them this question, that have you ever felt an electric spark from touching something or someone else? Now let the children answer this question. When they answer this question, they will relate their past experiences to the chapter that you are going to teach, and that may be electrical charge or static electricity or uh, electricity generation by friction or whatever. So when you make them connect the topic with their past experience, the connections will be building in their mind, and then it will be easy for them to take their new learning and connect it with a new situation altogether, because they have become used to making connections. So making connections, transfer of knowledge from one situation to another, that is a very very big competency. So if you're teaching physics, maybe you can do this. Or let us say, you can ask them, have you ever heard of anyone feeding their plants? Now tell me, what would your answer be? Answer please in the chat box. Have you ever heard of anyone feeding their plants? What would your answer be? Would you say yes, or would you say static electricity? Now, now we have gone beyond the static electricity. Please answer on this question. Have you ever heard of anyone feeding their plants? So someone is saying no. Someone is saying yes. Okay. So obviously there are two answers, yes and no. Jitendra ji is saying yes. Okay. Chandrasekhar ji is saying yes, giving water and whatnot. So now here the misconceptions are coming forward. You see, plants never take their food, because plants build their food. They are the primary builders, they are the primary cooks in the nature. So plants do not ever take food from outside, and therefore when you say yes, maybe some of the children will also tell you in the class that yes, we have seen people feeding their plants, we have seen them watering, we have seen them putting manure, we have seen people putting insecticides, pesticides, fertilizer, what all. But when they say this, we know that they don't understand the connection between photosynthesis and the ingredients required for photosynthesis. So from there, your class discussion can start that plants do not need any food from outside. So no one can feed them. We can only supply them ingredients for making the food, because then they will make their own food. And what are the ingredients? The sunlight, the carbon dioxide, the minerals, the water, and whatnot. Okay. So that is how you can make connections in the classroom, which is extremely important, because to make connection between real life situation and the scientific concepts, that is a very big competency that we are trying to build up. And then this will further extend to taking what they have learned in the classroom back to their life, where they can apply those scientific concepts. Because in isolation from our lives, science has no meaning. Science must be for society, and science must be useful for life. And that is what we have to inculcate in our children, that science is not for just getting marks or for higher education. Science is for solving the problems of society. Now, the third thing you may ask, have you ever watched water being drained from rice or pasta? Now, what would you say? What would the children say? That yes, no, they might have washed. If they washed, then you say, why was it being drained? Then children might tell you to separate water from rice. That means if rice was mixed with water, wasn't it a mixture? And then when you can take it further, that there are so many mixtures. Now you can ask them, what all mixtures have you seen in your life? They might come up, they may not, when you teach the chapter on mixtures, compounds, elements, they may not relate it to mixtures in their life. But you ask them, what all mixtures have they seen? They will tell you what all mixtures they have seen. They will connect with real life. They might come out with some compounds also, and then you can remove the misconceptions from there. right? The next competency is that when they make connections, and then there may be need to explore further. So when you need to explore further, you need to design experiments, and that is a very big competency. How do you design further exploration? How do you design further experimentation? So now supposing you give them a challenge, that suppose this is, I'm telling you, if your class could design a traffic light to manage the flow of children through the school, what would it look like, right? Supposing you're teaching electrical circuits to young children, okay? Now you tell them a corridor in your school is closed and you need to control the flow of children after playtime. So there is time for people to move safely from the playground to their classroom. If your class could create a traffic light, what would it look like? Right? Now, before they can even design, they can take material and make it. Let them just think about it and come out with their ideas. What do they think can can be done? Can they have? Can they discuss what would work without actually building a circuit? So, what are some ideas for their creation? So you can ask them, how will you light each bulb individually? So then they would tell us about their circuit ideas. We can say, how many wires will you need? Then will you need more than one battery, or even one battery will be sufficient? Then they might say that we may need switches to switch on and off lights one after the other. So whatever. The point is not that everybody should give us correct answers. The point is that they should be able to think of a way to design this traffic light. And if they are thinking of a way, then what are the materials they might need? What are the ways in which they may need to connect those materials? Can they do in minimum material? What would be the cost? So, this is just to get them thinking about it, get them to explore and plan and design, right? Then, what kind of switches will work best? Okay, how can you make different colors appear? So they may think about different LEDs, or they may think about bulbs. How can they do it in minimum cost? Okay. Then that was an experiment. But here there is an investigation which does not involve experimentation. How much electricity do we use? Right? Now, children know that they use different gadgets, they run different gadgets on electricity, but they may not know how much electricity is being used. So, again, how do you make them plan an investigation? Now, you can ask them what appliances use most electricity. Now, how do you think that they're going to answer this? What appliances use most electricity? Supposing these are your class 7 children, right? So write in the chat box, what do you think will be the answer from the children? What appliances use most electricity? What would you say the children might answer in your class when they are in class 7? Yeah. Can I see some ideas in the chat box? Mixer grinder, refrigerator, television, AC, heater. Okay. Now ask them, why do you think that washing machine, refrigerator, TV, they use most electricity, right? So first you have taken out their ideas. Then you are going to ask them that why do you say that these use more electricity? What is the basis of your saying that? So you are making them think about their own thinking, and that is critical thinking, right? So they might, now what might they say? Ask them, how will you explore this question? So some of them, they'll say, we looked at the plugs. There were some smaller plugs and some devices used bigger plugs, right? So they might say that bigger plugs are given to the devices which use more electricity. They may not know about anything else, but they might be looking at just the plugs. Then they might say, the bigger the fuse, the more the power needed. Some of them might have seen fuse also, that in some devices, a small fuse is attached. So the bigger the size of the fuse, the more the power needed. So these are their initial ideas. These may not be quantitative. These may be qualitative ideas, but nevertheless, the children are thinking as to how they can explore, right? Then you might also tell them that when you make an action plan, when you want to investigate, after you have explored, how will you present, or before actually carrying out the investigation, how would you present your action plan? Now, you see, when you ask them to present their action plan, you're asking them to communicate effectively. So here you are also nurturing their communication competency, because thinking about a exploration, a plan is different, and how to present the plan to others is different. Because when you want to present it to other people, you need to support what you're saying with some convincing argument. So, what is the logic in your presentation of your action plan? So, that is the logic. They will say, some who are saying that we look at different plugs. So, why they will look at different plugs? Because they think that bigger plug devices are the ones which use more electricity. So, in presentation, you require the logic also, right? And then we might also tell them that look at the things which are written on the tags on every device. Now, which one of them might tell us that how much power this device uses? Is it written somewhere? Now, when they look at different things, they will also figure out what are the things written, what is the voltage written, what is the power written. They might look at wattage, then we might tell them about kilowatt hour, the unit, and then how to calculate. But this is not about how to do it. This is about building their competency of planning or designing an investigation or designing an experiment. Then we can also give them problems to solve, right? How? We can tell them use everyday materials to make something to see round the corners, right? Now, yes, wonderful suggestion. Somebody's written they could see the devices which don't work on the inverter. A wonderful suggestion. I really applaud this suggestion. Wonderful idea. Okay, coming back to this. So we can also nurture the competency of problem solving. Now, how do we nurture that? We don't give them, let us say, description of periscope. We just tell them use everyday materials to make something to see round the corners. Now, how will they do it? Let them plan. We can give them a mix of building materials like foils, plastic milk bottles, boxes, straws, card, other bits of recycling material, and we can give them hand mirrors or mirrored cards, whatever. Now, ask them working as a team, create an object that will help to see round the corners. Okay. Think about the kinds of materials that will be best to use for this challenge. And can you think of any devices that already exist that you could borrow ideas from? Right? So this will set them thinking. And then when they make the periscope, right? Normally they think that periscope is seeing out of water, but it's not necessary. You can invert, you can tilt it, and you can see around the corners as well. Now, if you how you can also ask them that uh, see, they don't have box necessarily, they don't need boxes, they might bend straws and put it there also. So what are the alternate ways? So some groups will make with some materials, other groups will make some other material, and then exchange the material and see how other people's devices work, right? So that is the idea. Then they can, once they have thought of an experimental investigation, let them experiment. For example, you can look at this video. Just a minute. Is this not operating? Yeah. So here is a video. Now look at this video carefully. Now tell me what possibly they could be investigating with this. Write in the chat box what was possibly could children investigate with these three pieces. One is a metal aluminium piece, one is a wooden piece, and the other is a plastic piece, all of almost the same size. So, what could they experiment with these pieces? Yeah, transparency, density, temperature. Okay, wonderful. Conductors, conductivity. Okay, wonderful. So you might just give these to children and ask them that how can you use these to investigate some phenomena? And then I'll show you further what is the investigation that has been used here. Just 1 second. Yeah. So now look at the whole video. Okay, so what has been put on these particular pieces? Yeah, can you tell me right in the chat box what is being put? Eyes. Okay. Now tell me what data can be collected from this experiment. Write in the chat box what could children possibly measure in this particular experiment. Yes, there is no sound. Uh, no sound in the video. But tell me what data can children collect with this experiment? Yes, please. Reaction. What reaction? Yes. What can they measure? Heating effect, temperature, melting point. Melting point of ice, they know already. Uh, yes, temperature, conductivity. Okay. So if you were to ask them to measure and tabulate in a table, what could they measure? Yes, they can measure the initial temperatures of all the three pieces. Do you think they would be same or different? What can you say about the temperature of plastic, aluminium, and the wood piece? Do you think it would be same or different? Now, this is the way you could ask in the class also. It would nurture their competency of predicting and thinking, right? Then you can ask them to take stopwatches and measure the time it takes for the ice cube to melt, right? So time data can be measured. And then you could also tell them to write other observations, other interesting observations. For example, when the ice cube was put on the metal, it started moving, whereas in other two, it did not move. I'll show you again. If you notice very carefully, the ice cube was moving in this particular on this particular metal, aluminium. See again carefully. See, this is how it is moving. And then when they complete this experiment and then they write down the times that are taken to melt, for the ice to melt completely, can they infer something from that data? And that inference making is the most important thing. They have collected the data, but then how do they infer? How do they bring out the conclusion from the data? And then you can tell them the names, good conductor, bad conductor. Till now, do not tell them anything about good conductor or bad conductor. But then you can ask them to experiment. You can ask them to take more number of materials and experiment and then conclude where it melts fast, where it melts slow, and then classify into groups, one fast melting and the other slow melting. Slow melting would be called insulators and the others would be called conductors. See, this is how we develop competencies. Right now, we tell them in advance what is conductor, what is insulator. So they don't develop the competency of uh, collecting the data and inferring from that information. We are always giving them ready-made solutions. So we are stunting their capability of making inferences from the information. And that is the competency that we have to develop. Now, analyze and debate different ideas and test their scientific acceptability. Now, look at this concept cartoon. So, one person says chemical change causes electrons to move between atoms. Another one says some chemical changes can happen without any electrons moving. Fourth person says chemical change happens because electrons move between atoms. This person says electrons can move in metals without causing a chemical change. Now, these are the different alternative ideas. But which idea is acceptable scientifically? So, when children have the data and then they make an inference, we can also make them debate that what inferences are scientific and which inferences are not scientific. Now, look at this. This is an open ended uh, situation. The infographics, the data about how position is changing with time was collected and it has been represented in form of a graph. Now ask the children, what situation does it depict? What is the story here? Whose position is changing with time and how it is changing? Can you tell what story this graph is telling? Somebody might be saying that there is a dog which starts running from a position, then he looks at another, he finds another bigger dog, so he stays there, he just stops and stays at that position and then runs back after getting scared of the bigger dog. That is one thing. Then somebody might say that, okay, this is Radhika, she started from home and she went to a movie theater and then she watched the movie and then she came back home. So now here is a situation where here is a data or informatics which is uh, which is encouraging the children to come out with different stories. That means they are thinking of different situations in which this infographics can be applied. So you are developing the competency of applying information or information into real life situations, fitting the information into real life situation, that which real life situation could depict this situation. Not only that, supposing somebody says Ritika goes for a movie and returns home. Now, can you ask, was the movie interesting? Will you be able to answer this question if asked? Was the movie interesting? Write in the chat box. By looking at this graph, can you answer the question, was the movie interesting? If someone says that Ritika goes for a movie and watches it and returns home. So Prasunji, why are you saying that you cannot answer this question? Would you require more information? And if you require more information, what information would you require? So somebody is saying yes by taking time. Yes, definitely. If somebody were to tell you that in from how much was the time taken from here to here in going from home to the cinema hall and then from cinema hall to home, if that time is equal to, let's say, 3 hours, right? Or if the movie is of 1.5 hour, and if this time is 1.5, this time is 1.5 hour, that means the lady Ritika has spent that much time in the cinema hall. And if she has spent that much time in cinema hall, she must have found it interesting. But if this is half an hour, this is half an hour, and this is half an hour, movie was definitely not interesting, because that is why she has got up and left the movie in between. So you see, there are more things to look at. You can go deeper into data analysis, and that is another capability that we must develop in the children, right? Then going further, now give them new situations in form of case studies, because case studies are another situations where children can apply what they learnt in theory and understand, make sense of the situation. So I have here a situation about bee colony collapse disorder. An alarming phenomenon is threatening bee colonies around the world. This phenomenon is called colony collapse disorder. Colony collapse occurs when bees abandon the beehive. Separated from the hive, the bees die. So, colony collapse disorder has caused the death of tens of billions of bees. Understanding colony collapse disorder is important for people who keep and study bees. But colony collapse disorder also has an effect beyond the bees. People who study birds have identified an impact, right? So, this is the situation given. Now, the question is, the sunflower is a food source for both bees and certain birds. Bees feed on the nectar of the sunflower, while the birds feed on the seeds. Given this relationship, why might the disappearance of bees result in a decline in the bird population? अब क्या क्वेश्चन कह रहा है? क्वेश्चन कह रहा है कि सनफ्लावर जो है वो बीज के लिए भी फूड है और एक खास तरह की बर्ड्स के लिए भी फूड है. बीज क्या फूड लेती हैं? वो सनफ्लावर का नेक्टर लेती हैं, जबकि बर्ड्स क्या करती हैं? वो सीड्स खाती हैं. अब ये पूछा जा रहा है कि भाई, अगर बीज डिसअपियर हो रही है तो बर्ड क्यों डिक्लाइन हो रही है? क्योंकि उनका तो आपस में कोई रिलेशन ही नहीं है. बर्ड्स तो नेक्टर नहीं पीती हैं, बर्ड्स तो सीड खाती हैं, और बीज जो है वो नेक्टर पीती हैं सनफ्लावर का. जब वो एक जैसा फूड नहीं लेती, तो फिर ऐसा क्यों हो रहा है कि बीज की कॉलोनी, बीज जब डिसअपियर हो रही है तो बर्ड्स भी डिसअपियर हो जा रही है? अब आप क्या जवाब देंगे इसका? प्लीज टेल मी इन द चैट बॉक्स. सीड्स ग्रो इनटू फ्लावर्स, सो व्हाट? सीड्स तो आपके बचे हुए हैं, बीज मर गई, उन्होंने तो नेक्टर खा फ्लावर का लेना था, सीड्स तो उन्होंने खाना नहीं था. तो फिर ऐसा क्यों है कि जब बीज मर गई तो फिर बर्ड्स भी मरने लग गई? यस, कनेक्शन कहाँ है दोनों का? कनेक्शन कहाँ है? बात ये समझने की है. तो अब जो बच्चा ये समझता है, फूड चेन तो नहीं है, बर्ड्स तो बीज को नहीं खाती हैं, अगर बीज डिसअपियर हो जाएंगी तो बर्ड्स डिसअपियर नहीं होंगी. प्रॉब्लम कहाँ है? अगर आप ये समझते हैं कि बीज आर नीडेड फॉर पॉलिनेशन, एंड पॉलिनेशन के बाद ही सीड्स निकल के आएंगे, तो जब बीज पॉलिनेशन नहीं करेंगी तो सीड्स बनेंगे ही नहीं, और सीड्स नहीं बनेंगे तो बर्ड्स खाएंगी क्या? इसलिए उनकी पॉपुलेशन भी जो है वो डिक्लाइन हो जाएगी. तो ये इस तरह की जब हम सिचुएशंस देते हैं केस स्टडीज के थ्रू, then again we are nurturing the competency of children to be able to apply what they have studied in real life situations or new situations. The transfer of knowledge, ये जो competency है, इसको हम nurture कर रहे हैं. And then last is, give them situations whose implications they can understand and they can predict what will happen. Supposing we ask them, what if humans didn't have thumbs? What would be the implications? Right? And then what can they predict? Now, this is a very, very important competency, to be able to think of scientific implications and how we can predict. We can also bring in what are the animals who don't have thumbs, how their thumbs are different and our thumbs are different, why the thumb is needed. That is when the children will think about it, and then they will think कि अगर थम नहीं होगा तो क्या क्या नहीं किया जा सकेगा, right? So this is how we can strengthen their and nurture their capability of thinking in new situations and then find the solutions. And then this we can ask them to think and then become a pair, connect with their partner, exchange their ideas, and take the ideas further. So now this again is nurturing the competency of collaborative learning. Collaboration, communication, critical thinking, learning to learn, transfer of knowledge. All these general competencies have been nurtured through the process of nurturing scientific competencies. So that's all from my side today. Thank you so much. And these are my contact details. This is my mobile number, email ID. If you have any questions, any topics on which you would like me to take sessions, you're most welcome to write. These are my Facebook and LinkedIn pages where the information about different programs that I conduct is put up. So thank you so much. If that is all from my side, and if you have any questions, you're most welcome to ask.
Thank you, ma'am. It was very nice session, ma'am.
Thank you so much. So if there are any questions, I can take them up. Otherwise, I'll just leave the session. Thank you so much. Don't see any questions right now. Okay, thank you so much. Then I'll be leaving the session because I don't see any more questions. Thank you so much for your appreciation.
Okay, ma'am. Thank you.